All right, so it's 11:15 by my clock. So when do we get started here, folks? Welcome to yet another vendor session. It's a vendor session, but trust me, you will learn a few things in here. So again, this is GroupBy 2021. Thank you to the GroupBy organizers for having us here and letting us sponsor this wonderful, wonderful event. I have been watching the tweets fly by and all the social media posts regarding the event today, and I think things seem to be going fantastic. I haven't been able to tune in to many presentations, unfortunately. I only watched the latter part of Devon's and Andy's presentation there, but I have been asked to let this slide roll for just a little bit of time, so everyone is reminded of the code of conduct for the event today. And without further ado, this is me without the sunglasses, of course. I am a principal architect at Pure Storage, and I do technical sales. So I'm a sales guy. I try not to be that sales guy, though. I try to be a lot technical and a lot less sales, if you know what I mean. Like, I don't deal with numbers. Other people deal with numbers. I deal with the technology. And really my core function here at Pure Storage is to tell you guys how to implement SQL Server solutions on top of us and just have a great experience while doing so, right? Run your databases with great performance, leverage all the data services that we have to offer, and just change the way that you approach storage in general. Like, I've been hearing from a lot of friends and customers that we made storage cool again. I don't know that we can take credit for that, but we do try to give you a different experience for your SQL Server databases. So I'm a Microsoft Data Platform MVP, a VMware V expert, a Microsoft Certified Master. If you had even heard of that certification, it's a rest in peace at this point. And I did used to work at Microsoft on the SQL Server engineering team. I've been doing this for now 23 years. So it's been a long time of me working with SQL Server, etc. Thanks to the sponsors of the event today. Appreciate everything you do for the community. So thank you. And here's the session. We're going to call it Solving Data Protection and Recovery Challenges for SQL Server Databases. God, that's a mouthful. That's a mouthful. But I really want to focus on data protection and data recovery. Okay, I don't really want to deal with performance today. Okay, that's performance. Yeah, we can give you tons of performance. Right, we can give you performance as slow as 150 to 200 microseconds of latency for those transaction log writes that need to go uber fast, and tons of throughput or bandwidth for those checkpoints or backups or index scans, or for those things that require a ton of bandwidth. So I'm not going to focus on that today. That's something that we have been doing for close to a decade now. We have been giving you great performance. Our performance only gets better with every iteration of our product. So that's not something that I want to highlight here today. I'm not going to bother you guys showing you some specs on what we can do, blah blah blah. But I really want to tell you guys about our family of products. And I want to tell you about Pure Storage. I want to tell you about the things we do and how we see storage differently. Right? I don't just want to sell you or trying to get in your head the idea of a storage device that can do bytes in, bytes out super fast. Right? I don't want to sell you dumb storage that you can just write to it and read from it. Right? I want to sell you storage that helps you do a lot of interesting things. And these interesting things are really a spectrum of things, including data protection and data recovery. Okay, this is why I like to say that our storage devices do a lot more than just bytes in, bytes out. So this is the family of products that we have. Right on your left-hand side, you will see FlashArray X at the bottom. Right, that's our low latency, high throughput array. And then on top of it, you will see our FlashArray C, which is our high capacity array. Okay, so if you need your databases to go fast, you would use the one at the bottom. If you have a ton of data that you need to place into a storage device, you would use the one on the top. Now, if you have secondary workloads and things like that you want to place on a no flash array, you can leverage the one on the top as well. Now, we also have other products like Pure One, which is the management interface for your array so you just get a single panel of a view of your entire infrastructure. And then on the right-hand side, that white shiny device that you see there, that's Flashblade. Flashblade is purely a high throughput device. And when I mean high throughput, I mean exceedingly high throughput, okay? We'll talk about it a little bit more in depth as we go over this presentation. There's a couple more products that we have out there. One of them is called Cloud Block Store. Cloud Block Store, the way you think about it is one of the a flash array, like the ones that you have on your left-hand side, but running in the cloud. Okay, so Cloud Block Store is available today on AWS and also available in Azure. So if you want to leverage any of the data services, the features that I'm about to mention on the storage side in the cloud, you have the capability of deploying a Cloud Block Store, and they don't require you to use any of our devices on premises. If you want to leverage Cloud Block Store in the cloud without a flash array on premises, you can totally do that. You will still get all the benefits of our data services in the cloud. And then the last product that we have in our portfolio that I'm going to mention here today is Portworx. Portworx is a recent acquisition by Pure Storage, and it's now part of our family. And Portworx is really about Kubernetes and containers, and it provides tons of data services for those Kubernetes clusters and those pods running your containers. And so we're going to talk about all of these. Hopefully we'll see how much time we get to talk about all of these things, but let's talk about Flash Array first. Okay, that's been our marquee product for the longest time. You know, we have thousands of customers that are happy, have been using our Flash Array products for a really, really long time. But I want to highlight one particular piece of functionality from the Flash Array, and it's the fact that it's a data reducing array. So if you think about a storage device that does data reduction, we will always attempt to dedupe and compress every piece of data that you send to us, including your SQL Server databases. It doesn't matter what you send to Flash Array, we will attempt to dedupe it and compress it. So even if you send us a very large, petabyte-sized database, we will try to dedupe every that database against itself and against all the data sets that you have placed on the same array. Furthermore, we will try to compress whatever we have effectively not been able to dedupe. We will try to compress that. And we will try several different algorithms for compression to minimize the amount of footprint that your data actually takes on your storage device. Because the fastest I/O is the one that you do not perform, right? If I have to go over an entire data set that's laid out on my storage device, and I haven't deduped it and compressed it, then I have to deal with more blocks on the storage side. Let's think of that as blocks. But if I have deduped and compressed data sets, then I have less I/O to perform. That I/O is going to go faster, right? And so the natural side effect of that is you start to think what a volume or a LUN is. We don't really use the name LUN, but if you think about what a volume is on the array side, a volume that you will place your databases on, it's really a kind of a table with pointers to data sets that are spread throughout the entire array. So we don't really carve a portion of the array where we place your data sets in it. We don't do that, right? Rather, we'll create metadata structures that define what your volume is, and then those data structures would actually point to where your data actually resides. And we will do like 10 dB's raw version store does. We will treat the entire space of the array as an append-only store. So we won't ever overwrite pieces of data unless we absolutely have to. That's another thing that we do to make sure that your performance is optimal and to minimize or enhance the time that your flash will endure in your data center. So you don't ever have to, you don't really have to worry constantly about changing or replacing damaged flash modules from us. We don't even use SSDs anymore. We used to, back in the day, we used SSDs. Commercial SSDs, we will heavily adapt them to our architecture, but now we roll out our own direct flash modules, and that makes performance predictable. We control when garbage collection happens in those SSDs. We control overwrites in those SSDs, and we make sure that the write amplification factor of those SSDs is extremely small, meaning we don't have to overwrite a lot of things on an SSD just because we need to write a piece of data. So data reduction means a lot of metadata management. Things become really interesting when we can do metadata-based operations, right? So let's talk about how we avoid sites of data operations now. We have the data laid out in a given way where we can do metadata-only operations. That's interesting. If I can do metadata-only operations, then I can just take a snapshot of the metadata, and that's a snapshot of my entire volume, isn't it? That's a beautiful thing. So if my database is 2 petabytes in size, I can take a snapshot of that database in just a millisecond. The array has a REST API that you can call and ask for a snapshot of a given volume or given volumes if your database spans multiple volumes. We have a feature called protection groups. And that feature of protection groups is the basis for our consistent snapshots across volumes involved, right? So a snapshot is atomically taken across all the volumes involved. But it is also the basis for replication. So I can put my volumes in a protection group and I can replicate them to another array. Maybe on premises, I have another array that I want to replicate things to, another flash array, be a flash array X or flash array C. Or maybe I want to upload that data to the cloud. So I set up a protection group and I define a target for that protection group to upload my data to CBS, my cloud block store. Super interesting. And this is something that we talk a lot up here because we're super comfortable talking about this. Our snapshots with SQL Server databases will work 100% of the time. That is because we treat writes that you issue against the array very carefully. So you don't really have to use VSS snapshots for snapshots of your databases that work. You can take a snapshot in the midst of heavy processing for your database. It doesn't matter if you're pushing thousands of transactions per second against that database. The resulting volume from your snapshot, so your production volume, snapshot of it, clone that snapshot into another volume that you will attach to a SQL Server instance. That resulting copy of the database, number one, will be a metadata copy, so it won't actually incur into a full-on size of data copy when first clone, number one. Number two, it won't incur into any additional storage footprints the moment you take it. That resulting copy of the database will bring the database online every time. SQL Server will be able to go over that transaction log in your set of data files and bring your database online every time. That is fundamental to understand. And there's typically a lot of questions around this. So if you want to challenge me on this, I will explain exactly how it works, but you suffice it to say, the way that we handle writes on the array, we never acknowledge a write until we have multiple copies of the write on the array side, and then we acknowledge the write as completed. So when we take a snapshot, we snapshot that metadata, plus whatever writes have been acknowledged and not yet staged down to the flash. We construct your snapshot, then that snapshot can be replicated or maybe cloned into volumes to do whatever you want. So if I can take a snapshot that I can replicate, important to replicate, that constitutes a good copy of my database that I can actually potentially call a backup. If I can take a snapshot of my database, replicate it to another array, and on that target array, I can clone it into a volume or volumes and stick those database files into an instance of SQL Server and run CheckDB against them. That's a good copy of my database. That's a good backup. That's data protection. Furthermore, if you want to take application-aware snapshots, and by the way, tomorrow I have a session on GroupBy Europe where we'll be talking about snapshots in depth, and I will definitely talk about VSS snapshots. If you need point-in-time recovery at the database level, meaning restoring a snapshot with no recovery so that you can roll forward transaction logs on top of it, we absolutely support that use case. Okay, we have something called the SSMS extension, and there's an accompanying PowerShell backup SDK that the SSMS extension was built on top of. That SSMS extension is really just a plugin for SSMS. You install it in your SSMS jump box, and then you can start issuing snapshots against your SQL Server databases. And if you have them on protection groups, those will be replicated right away. So you can take snapshots of your databases that are considered backups as seen by SQL Server, and you can restore them with no recovery, so you can do interesting things. We will talk about those things in just a second, but this is very important. The snapshot is instant, and if you enable safe mode is one of our features that allow you to protect your snapshots even against somebody that has the highest level of privileges on the array side. So even if somebody is admin on your pure storage array, a snapshot that's taken with safe mode cannot be deleted out of the array unless you call support. Identify yourself with a key that support and you only know, and your account team has to be on the line. So if the bad guys take over your entire infrastructure, they are not able to get a hold of that data. Once you kick the bad guys out of your infrastructure, you just recover everything from your snapshots and bring your entire infrastructure as it was at the time of the snapshots being taken. This is wonderful. This helps you recover your entire infrastructure, all of it, in a matter of seconds. So you guys heard about all the ransomware incidents where they spent like days trying to recover? You don't have to do any of that with us, okay? If you get owned, God forbid it happens, once you kick the bad guys out of your network, you have cleansed your network, you have locked it down, and you're ready to restore your VMs and your databases. You just do everything on the array side without a size of data operation, which is exactly what happened to Colonial. Even after they had paid the pipeline, even after they had paid the ransomware fee, they were given the unlock keys. They started unlocking, but their data sets were so large that now they were spending way too much time decrypting all that stuff that had been encrypted by ransomware. And they decided that they may as well restore the backups. You see, when you have a storage device that can protect you from these things, it is such a different world, right? I take a snapshot of my database, I know it will restore and it will come online, right? I can just overwrite my crypto log volumes. I just overwrite them with my safeguarded snapshots on the array side. Thumbs up, right? So instant snapshots, instant ransomware protection, and all of this stuff is free, right? We're giving you great performance. We're giving you all of these data services with ransomware protection included for free. This is an interesting one. Remember what I told you about restoring your databases with point-in-time recovery? So no recovery restores from your snapshots. Imagine you have to seed an availability group replica on a 30 terabyte database. Or God forbid, you have to seed every single replica and you have multiple replicas. Say you have 3 replicas and you have 30 terabytes on each replica. That's 90 terabytes of data that you have to write. You also have to read them, by the way. You have to read those backups, restore them, and in order for you to join those availability group, the availability group, don't you? Or you do auto seeding, right? And what does auto seeding do? A backup behind the scenes, effectively. You have to read all that data and write it again. So avoid the size of data operations and leverage your storage devices to do this for you. Take a snapshot of your primary database, stick a snapshot with no recovery into every single replica that you need. If your replicas live in other arrays, no problem. Use the replication facilities provided by the array to seed those availability group replicas. Imagine that. Instead of spending hours or even days restoring all this stuff, do it in seconds. That's nice. Anyway, the gist of it is, if you have a storage device that can do size of data operations for you, you're completely deferring these operations to the storage device. I call that money because it's a lot of value in that. Replication of data sets, this is super important, and I'm actually working with a customer that has this issue. When you do availability groups and you're chugging through a lot of data, guess what you run into? Redo queuing. It's the first thing you notice, right? Your redo queues spike up, you have all this log to be transferred, you're having all this rather slow log redo happening on all the replicas. You're doing logical replication. Logical replication can be great, but it doesn't scale the way storage replication does. It never does, right? Replicating at gigabytes per second on pure storage arrays, that's a thing. Even against the cloud. So if you do a lot of ingest of data in the cloud and you want to bring that on-prem, we can help you with that, right? You can have SQL Server databases attached to Cloud Block Store, use Cloud Block Store as your conduit for bringing data on-prem, and vice versa. If you have data on-prem and you need to send that to the cloud, you can do that at gigabytes per second and not megabytes per second. Right? So efficiency of data transfer. Why is this so fast? Well, one of the many things that we do, besides writing good code, is making sure that we don't actually send data that already exists on the other side. This is fundamental. We don't ever send a piece of data to another pure storage array that is already there. Why would we do that? Flash array is a data reducing array. Cloud block store is also a data reducing device in the cloud. So if a piece of data exists on either, why would we send it? And even before we send a piece of data to the other array, we're not going to hydrate it. If we have a reduced version of a data set, why would we hydrate that data set before we send it? That makes zero sense whatsoever, right? So rather than doing that, what we do is we ask the target array, hey, have you seen this before? If the target array says, yeah, I've seen it before, then we send nothing. We just say, okay, well, just add a counter to it, increase the pointers, because that's it, right? We can do metadata operations. We don't have to send every single data set every time. So data reduction, again, at work here. And the amount of data that you can send is in much greater than the amount of data that you would have to send hydrated or non-compressed fashion. Excuse me. So I already talked about this, but I want to reiterate it. Your conduit to the public cloud is a pure cloud block store. Imagine having to lock ship a bunch of databases, or imagine trying to see them in availability group replica in the cloud, or a ton of availability group replicas in the cloud. If you leverage Cloud Block Store and RSSMS extension, you can do this in seconds, right? You simply take a snapshot of your AJ replica, have CVS be the conduit for you. Once your snapshot shows up in the cloud, which is going to take a few seconds or maybe a few minutes, depending on how much data you have. Once you have it in the cloud, you can just restore it with no recovery to your SQL Server instances in the cloud. Join your availability group. Did all that in just seconds, right? This is efficiency, really, storage level efficiency. Deferring operations to an intelligent storage layer makes a lot of sense for SQL Server databases. This is okay. Keep stressing these things that are kind of vital for DBAs to enjoy. And a lot of you guys didn't even know that you could do this at the storage level, or don't even trust the storage level to have consistency and provide recovery of your data 100% of the time, right? So we have a high level of confidence here. I'm going to pause here. Do we have any questions pending right now?
Yes, actually we do, Argenis. So someone was asking about the ransomware protection, and how many and what type of backups do you recommend for ransomware protection?
You see, that is very much an it depends question. We could probably spend hours talking about ransomware itself. I will tell you that you should at least take a snapshot for however much data your businesses can afford to lose. So your replication interval for your snapshots should be that of the RPO that your business is willing to withstand. So for example, if you have snapshots taken every 5 minutes and your RPO for your business is 5 minutes, that's a good strategy, right? How often should you take them? Probably every 5 minutes, like I said before. How often should you keep them? That's another question you should ask yourself. That's another important question, right? We can save a ton of snapshots on the array side. Naturally, they will consume some space to the degree that you modify your source volumes, but that gives you time machine-like functionality at the storage level. And that opens up a whole slew of use cases, including how did my data look like a week ago, which is great for investigations, right? For example, if you work on financials, I was just talking to a customer of ours that does this sort of thing, right? There is essentially investigators for data. They need to understand exactly what happened at the database level. There was some modification that triggered, an amount of money to go missing. What happened to that money? Having the capability of looking at your storage side for your databases or for any other data set and understand how that looked like a while ago can be very important. That's a great question. Any other questions pending there, Andy?
No other questions pending. You're doing great, Argenis. Keep going.
Awesome. All right, great. Thank you so much. So finally, we do all of this stuff that I mentioned before, right? All of these data services, all of this performance with no downtime whatsoever when you upgrade our devices, hardware or firmware on premises or in the cloud. We keep your devices are always online. Your VMs are attached. Your database volumes are online. Your FCIs will not go down. Your availability group replicas will remain on. Okay. There is no situation in which you have to take downtime, even if you're moving across generation of arrays, which we have done once already in our and during the history of Pure Storage. We moved from the FA400 series to flash array M into a chassis that is not the same chassis used for flash array X. In the future, we will have something else, right? Maybe we'll just continue using the same chassis, or maybe we'll have newer chassis for our newer storage devices. When we do, we'll always offer you a way to non-disruptively migrate your data sets. Or better yet, not having to migrate anything, which is exactly what we aim for, right? Every single Pure Storage array has been able to shift the hardware around the data and not the other way around, right? We don't force you to take data sets and shift them across arrays just so you can do an upgrade. Remember, I mean, if you guys are DBAs on the line, you're probably used to hearing horror stories about storage migrations, right? And having to do those every so often. Some contract with your storage vendor expired, and now you have to do a storage migration because you have, some new storage device you have to migrate to. Forget all of that with Pure. No more. You don't have to do that again, ever. We also offer you interesting capabilities for shifting data around if you have to ever move data sets across arrays because you're overrunning the array's performance capacity. So I run out of performance, right? Our arrays are great, but they're not magical, right? If you have a very heavy workload that you need to move to another array, you can set up active cluster, which is synchronous replication across arrays, and that'll help you move that workload seamlessly. That will also protect your workload in case you do lose one array. If you want to use that for high availability, they will protect the data that way, right? So active cluster is for high availability of data. Excuse me, scratch your throat. So active cluster, synchronous replication, and then active DR. By the way, synchronous replication works pretty much the same way that availability groups sync replicas work. So every single write is actually issued against the other array and only acknowledged on the primary array the moment that it's been hardened on the second, right? That's kind of how it goes for synchronous replication. Asynchronous replication, every single write that you issue against one array gets journaled and sent across to the pipe to the other array. But active cluster is sync, right? In the sense that availability groups replicas are sync in much the same way. And active DR is async in the same way that availability group replicas in async mode are asynchronous. So you can do all of these different models for protecting your data sets. You can do active DR against an array that sits on the other side of the planet, and you will get RPOs that are measured in seconds and not in minutes. So we will be replicating data extremely fast to them. Tons of customers leveraging these mechanisms. As a matter of fact, we are seeing customers favor that kind of replication over AG replication, or even log shipping or transactional replication. You can intermix snapshots with those models too. So if you have asynchronous replication of data, you always have the latest RPO from incoming replication, and then you still have the snapshots that give you the time machine capability for looking back at your data. Or because sometimes you want to restore as you were an hour ago, because somebody did somebody dropped a table in production and you didn't notice until like 59 minutes ago. You know what? You can go back to that snapshot that contains that data set, or you can just stick it as a copy of your database and do a select to fetch that table. Having storage that can do these things for you is important, right? It can save your cheese tons of times. Anyway, let's talk about Flashblade. Flashblade is our massive throughput device, and by massive throughput I really mean massive, okay? Whereas it's cute to talk about single-digit gigabytes per second, this can do multiple digits gigabytes per second, okay? So this is not just for backups and restores, which apparently our customers love doing that, because you can back up so fast and you can restore even faster. We'll talk about that in just a second. But it's also used for your big data, right? So if you have tons of unstructured data sets that you need to place into a high throughput device. So for example, in the SQL Server scenario, if you're just using big data clusters, that HDFS tiering portion of a big data clusters can reside on one of these devices and give you tons of throughput. So you don't have to ever hear the clicking sound of a hard drive in your data center again, right? So that's good stuff. This is really what Flashblade is meant to do. It's meant to handle very large data sets, tons of millions of billions or even trillions of files with ease. And specifically for SQL Server, not just big data clusters, but very much backups and restores. So let's talk about what we call the SQL Rapid Restore use case, because backups are great when they go fast, but rapid restore is even more important, right? I argue that if you have a device in your network today that you're backing up to, and you're slowly dripping bytes back to your primary device when you're restoring, you're doing it very wrong, okay? Because the goal is not to hit your backups to go fast. The goal is to restore fast, right? So that your business, when you suffer data loss, and you do have to recover from a backup, then you can do so as fast as you possibly can. And that's exactly what we're trying to sell you here, okay? Yes, we're selling you the idea of restores that go even faster than your backups do. So with the new version of Purity, which is the firmware on the Flashblade devices, what we call our operating environments, the version 3.2, we have a new rewritten SMB stack for it. And what you get on Flashblade is the capability of just pointing your SQL Server backups to Flashblade and use it as you would any share, any UNC path in your enterprise. That's simple, okay? You would just point your backups to that. So if you're using your own scripts, you would just use that those UNC paths on Flashblade. SMB shares, right? If you're using all Hallengren scripts, if you're using Minion, or even if you're using third-party backups through agent-based, like those are from Quest or Idera or Redgate, you can absolutely point those backups to go against Flashblade, and you will be enjoying speeds that are really measured in terabytes per minute. I'm going to say that again, terabytes of data per minute. So you're backing up at that speed. When you're restoring at the speeds that you have down there. That's just a speed that we show you. That's a test against the flash array. You can restore your entire environment from native backups at over a terabyte per minute. Okay, as you generate as you issue those restore statements against multiple databases at the same time, you would exploit the parallelism of Flashblade and get tons and tons and tons of throughput. We're literally talking, 15, 50, 75 gigabytes per second of throughput, like depending on how many chassis you have in your environment. This can be a game changer for your data recovery strategy. And remember, if you can't run flash array on your storage devices today, as your storage devices today for your databases, for your primary storage, well, you can use your Flashblades for backup because it works with every storage vendor. It doesn't matter if you're running your databases on DAS, PCIe attached, even if you're running them on storage devices from somebody else. It doesn't matter. You could use Flashblade as your backup target and enjoy all the throughput capabilities of it. So we don't only do SMB, by the way, on Flashblade. Flashblade speaks other protocols, and it actually has multi-protocol support for SMB and NFS. So you can have an SMB share where you took your SQL Server backups, presented as an NFS share to your SQL Server on Linux machines. So if you want to take a backup from Windows and restore it to Linux, you could do it that way. It's simple and super fast. And so this is something that we were ourselves blown away by. And we looked at the numbers from the competition and we're like, we couldn't possibly be that much faster. We are that much faster. Anyway, the architecture on how to exploit parallelism for your backups against Flashblade. Number one thing that you should know is SQL Server will generate one thread per logical disk seen by Windows. This is logical disk seen by Windows, not by physical devices underneath the hood. So even if you have one volume on your virtualized infrastructure for your VMFS data store, and you have multiple virtual disks, those will be multiple logical disks on Windows, and Windows will generate one thread for reading your database files from them. Okay, that will make a difference in terms of parallelism, which is exactly what you need here. All right, so that's for reads, your database files across multiple logical disks, one reader thread per logical volume. On the backup side, on the backup target side, you will generate parallelism at the rate of one writer thread per database backup file. So for every .back file, so you stripe your backup against multiple .back files, you will get tons of parallelism. On Flashblade, you will get even more parallelism by spreading your backup over multiple SMB shares. And this doesn't really complicate things because remember, you always have that information about how to recover from backup from your MSDB tables. Okay, so you can quickly just query them and construct, even if you're using DBA tools, for example, you can just quickly construct your restore statements from them, or just have DBA tools do it for you. Just saying, DBA tools is cool, and I love those guys. So this is effectively how you achieve high throughput for your SQL Server backups against Flashblade. It's super simple architecture. It's really nothing, you don't need agents. You don't need, to jump through hoops or configure a lot of things. You just point your backups to Flashblade and off you go. One thing that we have noticed though, and I gotta warn you, is that we will overwhelm your storage devices because we can back up so fast that you actually max out your storage devices as you read your backups. So you may have to be careful. Because if you have concurrent workloads at the time you take the backup, then those concurrent workloads may be affected by the fact that you're taking a backup so fast, which is totally a first world problem. Totally first world problem, right? I mean, you're at that point, you're effectively feeling what happens when you're enjoying really good backup devices. On the opposite scenario, when you're restoring, right, you can imagine parallelism comes on the reader threads on the backup files from having one reader thread per backup file, and then writer threads at the rate of logical devices seen by Windows. So you spread your database files across multiple devices, multiple logical disks, and you will get tons of performance there. I gotta warn you though, again, when you restore databases, you're gonna max out your primary storage device capability of writing data, of ingesting data, which is again absolutely the best possible scenario for your restores, because you want your restores to be as fast as they possibly can be ingested on your primary device. You don't want your backup target device to be the bottleneck. Flashblade removes that bottleneck from your equation. Your bottleneck will typically be on the network side. We have noticed there's a tons of different customers that their network is just, it needs a little bit of love before you can actually exploit all the capabilities of Flashblade. I don't think we have any questions as far, Andy, but please let me know if we do.
No questions. You do have another maybe 2-3 minutes so that we can give Klaus a couple of minutes to get set up and whatnot. So
sounds good. Okay, so let me wrap it up here. Number of volunteers, number of target backup files. I already told you guys this. Finally, what works is Kubernetes storage made the right way. So you can run any Kubernetes application, right? Any cloud native application, including SQL Server Linux-based containers, all right? Big data clusters, Azure Arc, and all of these things on top of us. And Portworx has great functionality for data protection, okay? You can take snapshots of your Portworx volumes. They're basically abstracting you from whatever implementation of storage you have underneath the hood, be it Pure Storage or somebody else. You can take snapshots of those databases on the fly, work every time. You can also take, you can back up entire Kubernetes clusters, maybe just namespaces, or maybe some particular pods using PX backup. You can also protect your entire Kubernetes cluster using PXDR. So if you want to have your Kubernetes cluster on-prem and have a complete Kubernetes cluster replicating NDR in the cloud, you can totally do that. If you want to do a multi-cloud scenario where you want to have some data sitting in Azure and that data replicated to AWS, you could do that, right? So we're enabling true multi-cloud stories, true cloud native protection stories with Portworx today. So if you're interested in hearing more about this, please feel free to reach out. Our website is purestorage.com. You can hit us up at purestorage on Twitter. It was a pleasure to speak to you guys today. Thank you so much for letting us sponsor this event. We do love GroupBy, and we'll continue to be partners for this wonderful organization as long as we possibly can. So thank you so much, you guys.